In this video, I will talk about vacuum pumps. There are two types of vacuum pumps. One of them is vacuum pumps, which is for the high vacuum pumps. And in the other part, I will talk about the high vacuum pumps. So these are the pumps, and we have three different vacuum levels. In the first level, in the rough vacuum, we mentioned about 1 atm to 10 to the minus 3 torr. So this is the rough vacuum, and it can be created very easily, by the way. In the other level, high vacuum, which is between the 10 to minus 3 torr to the 10 to minus 8 torr. And in this vacuum level, we can make sputtering, we can make some films, maybe a little bit thick films. And in the ultra high vacuum condition, we can keep the material clean, and achieving ultra high vacuum condition is pretty hard. So we have two different pumping systems for rough pumps, and we have high vacuum pumps. So high vacuum pumps generally needs rough vacuum pump. For instance, you have a UHV condition. If you have a UHV condition, you need a high vacuum pump and rough vacuum pump. Without the rough vacuum pump, generally high vacuum pumps doesn't work effectively, except ion pump. If you have ion pump, after a while you don't need rough vacuum pump, but I will talk about that. So in the first part, I will talk about rough vacuum pumps, and the name of the pumps: Rotary-Vane pump, scroll pump, and diaphragm pumps. So I will just mention about three of them. And in the second part, I will talk about the high vacuum pumps, which are turbomolecular pumps. Sometimes we just say turbo pumps. Diffusion pumps, the other name is membrane pump, ion pumps, and titanium sublimation pump, or TSP. So the first pump is Rotary-Vane pump, and this pump can sustain a pressure until 10 to minus 3 atm. So it is very cheap pump. This is the main advantage. There is an oil in the pumping system, therefore sometimes you call this is oil pump. Just it is easier to say Rotary-Vane pump. Gas molecules go inside the pump, and the vane moves. This part is turning, and we can expel the gas molecules. The disadvantage is that they are noisy. You have to change the oil. There will be oil leak always from the bottom of the pump. There is a general oil leak from the bottom of the part. And the other oil leak is actually the worst one. It can go to the chamber. So this is the main disadvantage of Rotary-Vane pumps. Therefore, we use an oil trap generally, or this pipe is very long, then you don't need to use the oil trap, but you have to be careful since oil contamination is always possible for the UHV systems. And by the way, if you don't know what is the UHV system, this is the UHV system. We want all the molecules out inside this system. So therefore, we call them as a UHV system, and this UHV system or ultra high vacuum systems has very low pressure. So this is our one of the UHV system, you can see. And in this UHV system, we have two backing pumps. And you can see the oil leaks. These are the pumps for the turbo. And you can see the turbo pumps here. One of them is this, and the other is here. You can see that. And these pumps, as you see or as you hear, is very noisy. So the other pump is the scroll pumps, and the scroll pumps is due to the scrolls. So name is coming from and just scrolls. Gas molecules go inside the scrolls, and by the way, this scroll contains tip seal. So this is a seal which is made of by Teflon. These pumps are quieter. So the main advantage is that they are very quiet. So I really like the quiet environments. So that this is my favorite pump. Whatever. There is no oil, so you don't have to change the oil for this pump, and you can keep the vacuum environment clean since there is no oil. Low maintenance, you don't have to change the oil like the other pump. They can sustain a good pressure. The main disadvantage is that they are very expensive. They are definitely more expensive than the Rotary-Vane pumps. You have to change the tip seal, but this is not a big issue. The main issue is that tip seals are not cheap, and changing the tip seals are really easy. Another issue, they are not very resistive to the corrosive gases. If you are working with the corrosive gases, you can damage your pump. And the last rough vacuum pump in this presentation is diaphragm pumps. So there's a diaphragm here, and this diaphragm moves. By moving this flexible diaphragm, and the gas molecules are vacuumed from the chamber. The main advantage is that there's no oil. Of course, there's a moving part, but there's no oil here. They are generally chemically resistant. If the diaphragm is chemically resistive, then the pump becomes chemically resistant, so that you don't need to change the diaphragm for a long time if you are not using the corrosive gases. But generally, we use the corrosive gases for these pumps, and I will talk about why. And the main issue is that we can't use them for the UHV systems. The main reason is that their pumping speed is pretty low. So disadvantage is that they have low pumping speed. They cannot create enough vacuum for the turbomolecular pumps or for the ion pumps. I will show them. And they are not suitable as a backing pump for the UHV systems. But they are very useful for the vacuum ovens. In vacuum ovens, we generally keep some dangerous chemicals inside it. For instance, if you have a very volatile organic compounds or some compounds that includes acids or bases, then you can use this pump. So if you compare the three of the pumps, Rotary-Vane pump, scroll pump, and diaphragm pump, ultimate pressure is 10 to minus 3 to 10 to minus 4 millibar for the Rotary-Vane pumps. For the scroll pumps, it is around the same, but the diaphragm pumps is not good enough for the UHV system since the pumping is not good enough for the diaphragm pump. So Rotary-Vane pumps includes oil, but the scroll pumps and the diaphragm pumps does not include oil, so they can sustain a very clean environment for us. There is a contamination risk for the Rotary-Vane pump due to the oil. There is no contamination risk for the scroll pump and the diaphragm pump. You have to change the oil for the Rotary-Vane pump. You have to change the tip seal for the scroll pump, and maybe you will need to change diaphragm for the diaphragm pump if you are using a course of gases. Otherwise, you don't have to change the diaphragm pump if you are not using the corrosive molecules. And the noise level is moderate, not the worst, but pretty high. For the scroll pumps and the diaphragm pumps, it is low. Pumping speed for the Rotary-Vane pump is high. For scroll pump, it is also high, but it is low for the diaphragm pump. So Rotary-Vane pump and scroll pump is useful for the UHV system, but diaphragm pump is not useful for the UHV system. The main advantage for the Rotary-Vane pump: low cost, robust, high pumping speed, and it can reach the low pressures. For the scroll pump, you can also use in the UHV system, and it is better. There is no oil, so there will be no contamination due to the pumping. Diaphragm pumps also oil-free, chemically resistive, and inexpensive. The main disadvantage of the Rotary-Vane pump: oil contamination. You have to change the oil 2 times in a year generally if it is working regularly. If you don't change the oil, then you may break the pump and it becomes very terrible for you. Scroll pumps are generally more expensive and you have to change the tip seals. For diaphragm pumps, pumping speed is very low, but they are chemically resistive. You can sustain a poor vacuum condition, unfortunately. Rotary-Vane pumps are common in the UHV systems. Scroll pumps also common in the UHV system, but diaphragm pumps are very common for the vacuum ovens. In the second part, I will talk about the high vacuum pumps. The first one is the turbomolecular pump. So this is the turbomolecular pump itself. You can see the blades. It's like a jet engine. And the rotational speed of these blades are very, very high, 20,000 to 90,000 RPM. Generally, the average is around 80,000 RPM, but it can be changed since you can change the pumping. by making some adjustments. This high speed allows the pump to transfer momentum to gas molecules and direct them toward the baking pump. So you definitely need a baking pump to sustain or to use the turbomolecular pump. Otherwise, the friction between the gas molecules and the blades will become very high and it causes a heating. If you don't use the baking pump for a while, if you remove the baking pump, after a while you will burn the turbo pump. And it is very expensive and your UHV system will become a junk. Whatever. Pumping speed depends on the pump size. Volumes change between 50 to 2000 liters per second. And pumping speed is pretty good for turbomolecular pumps so that you can make or you can perform sputtering very easily and effectively by using turbomolecular pumps. And turbomolecular pumps are not effective to pump hydrogen since hydrogen is very small. Therefore, you may need an ion pump to sustain a good UHV condition. Turbomolecular pumps are very reliable, so you can use them for 10 to 20 years. The main problem is the bearings. You need to change the bearings. If it is old, by the way, you can change your bearings by your own. However, if it is a new one, then there's a magnetic bearings and you can't change. So you have to send turbomolecular pump to the company and you have to pay thousands of dollars to change the bearings. And the wrong venting can cause catastrophic failure. Unfortunately, these turbomolecular pumps are very delicate. Somehow, if you change the pressure inside the system too high when the turbomolecular pump is working, then it can cause a catastrophic failure. And turbomolecular pumps cannot exhaust directly to the atmosphere. Baking pump is very important. And you can understand how baking pump is working effectively. If you have a turbo pump and if you have a, for instance, Rotary-Vane pump, and if your Rotary-Vane pump is not working properly, then you can check the current that is used by the turbomolecular pump. If the current is high, more than 1 ampere, then you can say that your Rotary-Vane pump is not working properly, or you have to change the tipsels of the scroll pump. And the main issue of the turbomolecular pumps, they are extremely expensive. The other pump is diffusion pump. These are not currently commonly used in the UHV system, and you will understand the reason why. A diffusion pump is a high vacuum pump that uses high-speed jet of heated oil vapor to transfer momentum to gas molecules and direct them toward the baking pump. Unlike turbomolecular pumps, diffusion pumps have no moving parts. And there is oil here, and this oil is heated. There's a heater. And there is also water cooling pipes. The oil inside the pump always moves. It interacts with the molecules and exhaust them from here. And you can see the water cooling pipes. There's a moving part actually here. The oil is moving, and the second thing is water is moving. So there's a water circulation and there is oil circulation in this pump. The main uh, advantage, the pumping speed, it is extremely high, and operating rate is 10 to minus 3 to 10 to minus 10 millibar. But it requires a backing pump and there is no moving part except oil and water. The main advantage is that high pumping speed, low cost, reliable, and very long service life, but you have to change the oil. And the other issue is that oil backstreaming. What does it mean? This oil inside the pump can go to the UHV system and you will have to back your system if this happens. It requires a cooling water, so you may need a chiller. It requires start-stop time, 30 minutes to 1 hour, it changes. And oil must occasionally replaced in the pump. Another high vacuum pump is the ion pump. And ion pump or sputter ion pump is one of the most important pumps used in UHV systems. Unlike mechanical pumps or turbomolecular pumps, ion pumps do not remove gas by physically transporting it out of the chamber. So these pumps actually absorb the molecule. Instead, they ionize gas molecules and permanently trap them inside the pump. How does it work? So there's a gas molecules in the UHV system, right? You took many of them by using, for instance, a scroll pump, whatever. And the other gas molecules are ionized inside the pump, and these ionized molecules, by the way, they are ionized by the electrons since there is an electron flow inside the pump, and positive ions are created due to the electrons, and these positively created electrons are buried in the cathode material. So we have a cathode material and the titanium, and titanium can react with the ion also, and you can chemically absorb the gas molecule inside the pump. So molecules were not exhausted from the chamber. Pumping speed is low for the ion pumps. If you are making, for instance, argon sputtering, it might be an issue. The reason is that these pumps are not very effective to pump, for instance, argon, neon, or helium. And operating pressure range is 10 to minus 5 to 10 to minus 11 millibar, which is an issue a little bit since 10 to minus 5 millibar is generally used for sputtering, right? So if you are trying to make sputtering, you'll definitely encounter some issues, but it is possible. I made it. I performed sputtering by using ion pumps. I had to, unfortunately. So by you have to be careful since ion pump can shut down and you have to break the system again. So it is a possibility. It didn't happen to me, but it is possible. There's no moving parts, of course, and the main advantage is that they are very silent. You don't hear anything, and also the other good thing is that you don't have to use a baking pump after a while. So only one ion pump can sustain a UHV condition. It is possible. Oil free and low maintenance. You may need to change the cathode material, but other than that, it is very reliable and there is no vibration. The main disadvantage is high voltage is required. It can be dangerous, therefore this is a disadvantage. 2 to 7 kilovolt is used to create the electron flow. Performance depends on the gas, so you can't pump the helium, neon, and argon. And if you remember, for the turbomolecular pumps are very bad for the hydrogen, but ion pumps are good for the hydrogen. So ion pump and turbomolecular pump can work together and sustain 10 to minus 10 torr very easily. Using ion pump and turbomolecular pump together might be very effective, and the limited pumping speed is another disadvantage. You may not perform the sputtering. And the titanium sublimation pump, it is basically a titanium. There are titanium filaments here. You apply a high current to titanium filaments, 40 amps to the 50 amps, and titanium reacts with the gases like oxygen, carbon dioxide, CO, and water. And operating pressure is 10 to minus 6 to 10 to minus 11 millibar, but it requires a backing pump and filament can burn. These are used as a support pump actually. So if you have a UHV system, for instance, water is the biggest issue. And if you have a titanium sublimation pump, you can get rid of from the water since hot titanium filament will react with the water and it will create the hydrogen, and hydrogen created hydrogen, dimolecular hydrogen, can be expelled by using other pumps. So it is very useful to remove the water molecules. And the main advantage is that they are very cheap. You just need to change the titanium filament, that's all. Very reliable. You have more than one titanium filament. So if you burn one of the titanium filament, you can continue to use another one, and you can use also another one. So it is very easy to operate. The most important thing is that when you are operating a titanium sublimation pump, you have to watch the pressure. If the pressure exceeds 10 to minus 5 torr, for instance, you can damage the turbomolecular pump. How can it be achieved? If your system has high amount of water, you will create hydrogen gas, and created hydrogen gas can increase the pressure a lot. So therefore, you have to watch the ion gauge measurements. And the disadvantage is that this pump only pumps a few molecules: oxygen, carbon dioxide, carbon monoxide, and water. That's all. And you can see the comparison of these three high vacuum pumps. So the most important parts are: turbomolecular pump cannot effectively pump the hydrogen. Ion pump is very bad for the helium, neon, argon, and methane. Titanium sublimation pump is very ineffective for the helium, neon, argon, methane, or whatever. And diffusion pumps are not effective for the light gases. So maintenance is a big issue for the turbomolecular pump. Ion pump, you need to change the cathode material itself, but it lasts maybe 10 years, so it is not a headache. For the titanium sublimation pump, you have to change the filament, but you have more than one filament generally, so this is not a big issue. So for the diffusion pump, you will need to change oil, and cooling system maintenance is also important. So in turbomolecular pumps, there is no vibration, maybe very low, very low. If there is a big vibration, probably your turbo pump will die very soon. Ion pump, titanium sublimation pump, and diffusion pumps, there is no vibration since there is no more part. Contamination risks are very low, except diffusion pump. All of them are suitable. All of them is suitable for the UHV systems, but only ion pump can be used without vacuum pump. The main advantage of the turbomolecular pump is the pumping speed, and they are very clean. Ion pumps are very clean, but you can't pump the argon, neon, or other molecules, so it is the main disadvantage. Titanium sublimation pumps only react with a few molecules, especially water, so they are not directly suitable for the HV systems. Definitely you need other pumps. And main disadvantage of the turbomolecular pump, they are very expensive. They require vacuum pump. Ion pump, main disadvantage, they are not useful with noble gases. Titanium sublimation pump has very low pumping speed, and they are only used, they have finite capacity. And in diffusion pumps, oil contamination is the main risk. So I hope this video was useful for you. And if you have any kind of question, you can ask in the comment section.